Good day, gentlemen. I am Captain Neeraj from HIMT, and today I'll be taking you all through some frequently asked questions by DGS Shipping in their exit exam for liquefied gas tanker cargo operations. So now, the overall structure of the test is that it is divided into 5 subsections, and each of the sections are important. There will be questions from each of the sections in your examinations. So firstly, the most important topic is IGC code, followed by chemistry of gases, then properties of LNG, cargo machineries, and lastly emergencies. So let's start with some of the frequently asked questions from section 1, that is IGC code. So question number 1, LNG carriers are designed and constructed to meet the stringent standards of which code? As I am talking you already about IGC code, so again the answer of this question is IGC code. IGC stands for International Code for the Construction and Equipment of Ships Carrying Liquefied Gases in Bulk. Please understand that this code is only applicable for ships constructed after 1st July 1986. There are other codes which are applicable for the ships which are constructed prior to this deadline. So the correct answer among all the options given for this question is IGC code, that is International Code for the Construction and Equipment of Ships Carrying Liquefied Gases in Bulk. Moving on to question number 2. What is the IGC code definition for a liquefied gas? Please understand the definitions as per IGC code. We are not talking about chemistry classes, we are talking about IGC code. So products having vapor pressure exceeding 2.8 bar absolute at 37.8 degrees Celsius and products mentioned in chapter 19 of the code. Please understand the key point here is the pressure 2.8 bar, temperature 37.8 degrees Celsius and products of chapter 19. All these 3 elements are important when we define a liquefied gas based upon IGC code. Among all the options given for this questions, option Bravo, that is products having a vapor pressure exceeding 2.8 bar at 37.8 degrees Celsius, that is 100 Fahrenheit. This is the correct option to choose for question number 2. Question number 3. What type of tanks are completely self-supporting and neither form a part of the ship's hull nor contribute to hull strength? This question is also from IGC code, where the different types of tanks are divided, where the different types of tanks are elaborated. So the basic classification is independent tanks and membrane tanks. Independent tanks are further subdivided into 3 parts, that is tank type A, tank type B and tank type C, based upon their secondary barrier. However, the answer to this question is independent tanks, that is this type of tanks does not contribute to the hull strength or they do not form the part of the ship's hull. So for all the options given in this questions, option number 3, for question number 3, the option alpha, that is independent tank, is the correct choice to make. Question number 4. What type of gas carrier based upon hazardous nature of cargo which has maximum preventive measure? So for this question, again we have to refer to IGC code. IGC code further subdivide liquefied gases into 4 parts, that is tank ships type 1G, 2G, 2PG and 3G. Each of them, the classification is basically based upon the nature of the cargo that they will carry. Type 1G ships are the one which will carry the maximum hazardous cargo. Type 2G slightly less. Type 2PG are basically pressurized, and 3G are the one where we have minimum preventive measures. So the answer to this question is type 1G. So question number 4, that is answer is type 1G. Option alpha is the correct choice to make. Question number 5. The carriage of LNG requires a certificate of trading called as. So this certificate is referred to as the International Certificate of Fitness for the carriage of liquefied gases in bulk, also called as in short Certificate of Fitness or COF. This certificate is quite important for this type of vessels. Why? Because it not only it states the cargo which you will carry, also states what code is applicable for your vessels. As I told you about IGC code, there are other codes as well. It also defines the type of tanks which you have discussed in the earlier questions. So this certificate is basically the summary of your entire construction process. So among all the options given for question number 5, option Bravo, that is International Certificate of Fitness for the carriage of liquefied gases in bulk, that is the correct choice to make. Moving on to second section, that is chemistry of gases. Please understand this section is very, very important. There are not only questions in LGTF, but there are questions in your GasCo program as well for this section, chemistry of gases. So question number 6, how can gases be liquefied? So first and foremost thing, to liquefy a gas, we either reduce the temperature or we increase the pressure. There is third way where we can use a combination of both. Temperature, that is your reduction of temperature, and increasing of pressure. However, to answer this question, we have only two mechanisms, that is by reducing the temperature or by increasing the pressure. So the correct choice to make is option Bravo, that is by the application of pressure or by cooling. Moving on to question number 7, what is LNG liquefied for sea transportation? So why is LNG liquefied for sea transportation? To answer this question, we have to understand the expansion ratio of LNG, that is 1:600 times. So this makes it more economical for transportation. It makes more sense to transport in a liquefied form than into a gaseous state. So the correct choice for this question is option Delta, that it makes more economical for transportation. Moving on to question number 8. Question number 8 is very, very important. It talks about the gases law and it refers to Lusak's law. What about the Lusak's law? What is the relationship between pressure, temperature and volume? To answer this question, we will look into PVT triangle. Here, the relationship between pressure and temperature is defined by Lusak's law, and it says that pressure is directly proportional to temperature. In order to make it a mathematical equation, we will use a constant. So the equation looks like something like this, that pressure is equal to constant multiplied by temperature. So the correct choice for this question is option Charlie, pressure is equal to constant multiplied by temperature. Moving on to question number 9, same gases law, but this time as per Charles law. So Charles law talks about the relationship between volume and temperature, which is again directly proportional to each other. And again, in order to make it a mathematical equation, we use a constant. So among all the options given for question number 9, the correct choice to choose for is option Delta, that is volume is equal to constant multiplied by temperature. Question number 10, again it talks about Boyle's law. So Boyle's law defines the relationship between pressure and volume, which is inversely proportional to each other. In order to make it a mathematical equation, we will use a constant. So for this question, all the options given, the correct choice to choose is option alpha, that is pressure is equal to constant divided by volume. Moving on to question number section 3, that is basic properties of LNG. LNG, that is liquid methane. What is the boiling point at atmospheric pressure? So to answer this question, LNG boiling point at atmospheric pressure is -162 degrees Celsius. Please understand the unit which we are using. We are not using Fahrenheit, we are using Celsius, and it is -162. So for this question, all the options are given here. The correct choice to choose is option alpha, that is -162 degrees Celsius. Question number 12, LNG vapors explodes when it is mixed with air within the flammable range of. So this question talks about the flammable range, that what is the LEL and UFL for LNG, that is the liquid methane. In very crude terms, it is between 5 and 15 terms. In actual terms, it is slightly higher than 5 and it is slightly lower than your 15%. So answer to choose for this question is option Bravo, that is 5 to 15%. As I told you all, the is a crude terms. Actual value is slightly higher than 5 and it is not 15%, it is slightly lower than that. But again, the options are not there. Question number 13, which of the following is the characteristics of LNG? So LNG is basically a colorless, odorless and non-toxic gas. These properties makes it very convenient to use as a fuel. So among all the options given in the question, all are correct. That is, it is odorless, it is non-toxic and it is colorless. So the correct choice to make is option Delta, that is all the above. Question number 14. After unloading liquid from a cargo tank, small quantity of cargo is not pumped out, which is called as. This is the one of the basic operations for a gas tanker, where we keep some of the cargo, and we don't discharge the complete cargo. This residual cargo which we keep after the discharge of LNG is called as heel. So among all the options given for this question, option Charlie, that heel is the correct choice to make. Question number 15. What is the main reason for a membrane class LNG tanker to retain heel during a ballast passage? So why we are retaining the heel this time? So first of all, what we retain is called as heel, and second is why we are retaining the heel. So heel we are going to retain. The reason is because we want to keep our tanks in the sub-zero conditions, in the cryogenic condition, so that my tanks are ready for the subsequent voyages. So the answer to this question is to maintain full temperature inside the cargo tank. That is option Bravo. Moving on to question number 16. What is the designed boil-off rate for a typical membrane type LNG carrier? So that is the designed boil-off rate. So boil-off rate should not exceed 0.15% of the full cargo tank capacity per time. Boil-off rate should not exceed 0.15 of full cargo tank capacity. Now, these are the maximum limits what we are talking about. These are the maximum limits. So again, among all the options given, option Bravo, that is 0.15% of the full cargo tank capacity, is the correct choice to make. Please understand, we are talking about the maximum limits. These are not the minimum limits. There are ships which are delivered in 2019, 20 and 21 where the boil-off rates are quite low and they are practically 1/3 of this value, that is almost 0.05%. Moving on to question number 17. What is a cofferdam? So cofferdam is basically one of the typical design characteristics of LNG ships. Basically, it is an empty space separating two cargo tanks. So among all the options given for this questions, option Bravo, that is wide or empty spaces separating two cargo tanks, is the correct choice to make. Moving on to section number 4, that is cargo machinery. Cargo machinery, we'll start our question with question number 18. How would you determine if a submerged LNG pump is working correctly? That is pumping at the correct rate. Please understand, the submerged LNG pump is basically driven by currents, is developed by electric motor. These pumps are submerged inside the cargo tank. We cannot see how they are functioning. We have to rely on the reading of this motor, that is the reading of the current. Basis that reading, we can judge whether the pump is working correctly or not. So the answer is ammeter. Ammeter is a gauge which defines the current that is being drawn by the pump. So the option to choose for is option delta, that is check the motor amperage. Moving on to question number 19. A pump used to increase the discharge pressure from another pump, such as a cargo pump, is called as a booster pump. Basically, booster pumps are found on LPG ships. The whole idea behind this booster pump is that they are going to increase the discharge pressure from your main cargo pumps. They are not the main pumps. They increase the pressure of the cargo which is being drawn by the main pump. So among all the options given for question number 19, option delta, that is booster pump, is the correct choice to make. Moving on to question number 20. Which cargo equipment is provided on LNG tanker to convert LNG liquid into LNG vapor? Please understand, we are talking about LNG liquid into LNG vapor. So this is basically called as a vaporizer. It is not a fancy equipment, it is basically a heat exchanger and the name is vaporizer. What it is doing, it is converting liquid into vapor. So vaporizer is the correct choice to make, that is option Charlie. Question 21. Which cargo equipment is provided on LNG tanker to convert LNG vapor into LNG liquid? Now we are talking about from vapor into liquid. Again, it is also an heat exchanger, but this time it is called as a reliquefaction system. Each type of ship, whether it's LNG or LPG, they have a different design and a different working model for a reliquefaction plants. So the correct choice to make for question 21 is option Bravo, that is reliquefaction plant. Question number 22. IGC code requires each cargo tank to be fitted with at least empty spaces, liquid level gauge. So how many liquid level gauges are required as per IGC code on each tanks? So as per the code, minimum 1 liquid level gauges is required for each of the tanks, minimum 1. So the correct option to choose for question number 22 is option Bravo, that is 1. Question number 23. When a float gauge is not in use, where should the float be? So the answer to this question is, if you leave the float hanging, it can damage your tank systems, it can get itself damaged. So it must be retrieved and housed. That is the correct choice to make. Now, among all the options given, option Charlie, the float should be retrieved and housed, is the correct answer. Question number 24. Setting can be changed on pilot operated relief valves to increase the lifting pressure as long as this does not exceed the MARVS. What does MARVS stands for? So MARVS are basically relief valves. The word MARVS stands for maximum allowable relief valve settings. What you are looking in your photograph is one of the MARVS of the MARVS type LNG ship. So the correct choice for question number 24 is option alpha, at maximum allowable relief valve settings. Now moving on to our last section, section 5, emergency. Question number 25, if all the pumps fail in a MARVS type tank full of liquid LNG, what would you get the cargo out? So if my tanks fail, as I told you, tanks are submerged inside the cargo. The pumps are submerged inside the cargo. So how are you going to pump the cargo? So in order to do that, please understand the construction of the tank is itself in such a way that these tanks can be pressurized and the liquid can be pumped out. So the answer to this question is pressurize the tank to push the liquid out. That is brown. Now we move to question number 26. If all the pumps failed in a membrane type tank full of liquid LNG, how would you get the cargo out? Now this time in a membrane ship, the submerged pumps failed. How am I going to pump out the cargo? The design of the ship is such that we have no option to increase the pressure. These tanks cannot take the increased level of pressure. However, there is an emergency procedure where we can lower an emergency pump inside a special designed emergency column, which itself has a foot valve, and this valve operates by the weight of the pump. However, there are specific procedures to do that. In order to answer this question, the correct option to choose is use of emergency cargo pump. That is option Charlie, use of emergency pump. Question number 27, propellant for fixed type DCP systems used on LNG carriers. So DCP systems, the propellant which we use on ships is nitrogen gas. What you are looking in the photograph, red color is DCP and the gray color bottles are the nitrogen gas bottles. So these are the propellant for your DCP installed on LNG ships. The correct choice to make for question number 27 is option alpha, nitrogen. 28, for what purpose do we have deck water spray system on board gas carriers? So deck water spray systems, the reason why we have on board, because it can flash cargo spills and cool down that area, cool down the tank in case of a fire. So now if we do not have the system, what is going to happen? My hull can have a brittle fracture. Deck hull can get a brittle fracture because of the cargo, this cryogenic cargo. So the correct option to choose for question number 28 is option Bravo, flash cargo spills overboard and cool down the cargo area. Question number 29, following are the means of links available on board to connect ships ESDS to shore ESDS, except ESDS is one of the key component of gas tankers. And how am I going to connect a ship ESDS to the shore ESDS? That is emergency shutdown system. So this is one of the ESDS panel from one of my vessels. That is, we have optical systems, we have electrical systems, and we can also have pneumatic systems. So these are three systems as of now which we use on board the vessel to connect the ship and shore ESDS systems. Again, we have to sort out in the options given, we have to sort out the option which is not available. So Bluetooth link is as of now not available. Maybe in future we might have it, we never knew. But as of now, Bluetooth link is not available that we can use it for ESDS systems on board. Question number 30, that is the last question for this session. What is the melting point temperature of the ESDS automatic fusible elements normally fitted on board? So ESDS systems can work manually. You can go and trip it manually. It also works automatically. You can go and it gets activated automatically when we have a fire, when we have any safety parameters breached, like your tank levels, temperatures, pressures, fixed firefighting system getting activated. So it can get automatic activation as well. In case of fusible elements, which looks something like this, so what you are looking on top is basically an electrical link and the bottom one is a pneumatic link. These are designed to operate between temperature of 98 and 104 degrees Celsius, not below this and not above 104 degrees Celsius. So correct choice to make for question number 30 is option delta, that is between 98 and 104 degrees Celsius. So this brings us to the end of our discussions. I hope you all managed to extract some value out of it. Just to keep you all informed, we at HIMT are also conducting advanced gas tanker course, that is GASCO. Please feel free to book the courses. This is Captain Neeraj signing off. I'll see you all in my upcoming videos. Thank you.